In this video, we will show how Singlipix's visualization technology can be used to enhance and validate an existing study on postoperative tonsillectomy bleed rates. Specifically, we are focused in on this top sphere here, which shows the hospitalization from bleeding codes after a tonsillectomy. The glyph itself that we have for the visualization is split up into 4 spires with 2 inner elements. The central element is a pill that gives the category name, percent total, and number of patients, while the middle ring gives the codes per patient. Finally, we have a bleed code spire, an infection code spire, a non-infection code spire, and finally a common codes per patient spire on here. Each spire is broken out into the specific codes that are related to that individual or that grouping. For example, this element right here is related to tonsillitis abscess infections. Each element will range from blue to red based on whether it is a low percentage or a high percentage versus the population. Blue tends to be good and red tends to be bad. As we go to the visualization itself, we can see that we have several related categories that form along each row. For example, we have 5 age glyphs in that category, 2 gender glyphs, and 4 region glyphs. From an eagle eye perspective, what we're looking for here are top elements that are not blue in color. Specifically, we can see that there is a single location that seems to be much higher than the norm, a single race that seems much higher than the norm, and 2 age categories that seem higher than the norm. If we focus in on the age, we can see that for the age groups between 18 and 65 years, we have bleed rates that seem to be much higher than average. As a frame of reference on here, the average population bleed rate is roughly 0.03. In the 18 to 35 year category, we can see that it is almost double the population, and within the 36 to 65 year category, it is over 4 times the average. This is good because it validates the study that was originally done that indicated that older patients seem to have a higher bleed rate versus the population. In comparison, individuals that are under the age of 17 have bleed rates of only 0.016 and even lower at 0.007 for the very youngest. What a visualization like this also shows is that you might want to look at things in addition to age on here, such as race, and try to determine why Hispanics have almost twice the average bleed rate, or why an individual location here, which has 529 patients, has a bleed rate that is over double the average.